All right, so picking up where we left off with the trigonometry review, let's look at this. So we're going to kind of do some applications here. So the only applications you're going to kind of have to deal with would be angle of elevation and angle of depression. So right now, if you look up at a 62-meter tall building and find that the angle of elevation from the ground to the top of the building is 51 degrees, how far away from the building and the base are you? So always try and draw a picture with this. So we have a 62-meter tall building, and the angle of elevation from the ground to the top of that building is then 51 degrees. So there's a distance here that we don't know how far away, and that's what this is telling you right there. How far away from the building's base are you? So here's the base of the building, here's the top of the building, here's where you are standing. And since we're at an angle of elevation of 51 degrees, that's talking about the incline. That's me looking up at the top of the building. So anytime you're looking up, it's an elevation. So elevation, you want to think of this as looking up at something. So now if this is my unknown variable x, we now are looking to find that value. So since we're at the ground, we have the O, the opposite and adjacent. So we're going to then go tangent of 51 degrees is equal to 62 all over x. And to solve, we put it over 1, we cross multiply, so we get x tangent 51 is equal to 62. So then x is equal to tangent of 51 divided by 62 in this scenario. Tangent of 51 divided by 62 gives us oh, I'm sorry. We need to back up here for a minute. Apologize for that. I made a mistake on something when I wrote. What I should have said is we take 62 and we divide that by the tangent of 51. Since we're solving for x, we're dividing by tangent of 51. And you get x then is equal to 62 divided by tangent of 51. X is then equal to 50.2 meters. So that ends up being the distance that we are currently looking at and how far away we are from the building at a 51 degrees of elevation. So let's look at a different scenario here. So now Joe stands at the top of a cliff that looks down at a 49 degree of depression at a boulder that is 17 meters away from the bottom of the cliff. So he is standing here. So here is Joe. He is looking down at a 49 degree of depression. So the common mistake is that people tend to have the issue, where does the 49 go? This is his eyes original line of sight is going this direction. So since this new line of sight is going down, that is where the angle is being created. So this becomes the 49 degrees. And the 17 meters that we have left is where the boulder is currently sitting from the cliff. So the boulder to the cliff is 17 meters away from the bottom of the cliff. How tall is the cliff? Well, then that's the value that we're looking for. So one thing we want to keep in mind, especially on this problem, is the fact that this 49 degrees is on the outside of this angle. So you have two options. You could A, find the value of this angle here, which would then be 41, because this has to be a 90-degree angle. Or, I don't like to create more work for myself. I like to create basically a rectangle or a rectangle out of this, knowing that this is 49. That means this distance from the person to the ground and this distance here down to there has to be the same. In order for them to be the same 49 degree angle, the height of the two images have to be the same, which means the distance has to be the same. So I'm going to kind of redraw my triangle as 17 and x. There's my angle. Here's 49. So therefore, to solve for x, then is then another tangent, because I'm giving you the O and I'm giving you the A. So tangent of 49 is then equal to x over 17. And now we cross multiply and we get x is equal to 17 tangent of 49, which is then equal to 19.56. So we would say 19.56 meters would be the distance, or how tall the cliff is in this scenario. Now you're going to get the same answer if you use 41. The only difference is that your setup then would be, instead of 49, you're using 41. You would go tangent of 41 is equal to 17 over x. So instead of multiplying these two values like we did here, we're going to take 17 and divide it by tangent of 41, and you're still going to get the same answer of 19.56. Just the difference is that you're taking 17 divided by tangent of 41 rather than 17 times the tangent of 49. It does not matter which way you go. Both of those will work. Just keep in mind that elevation was looking up, so that means if we talk about depression, we are looking down. So the example I gave in class was the baseball pitchers throwing the ball down to the catcher, where the elevation would be the hockey player shooting the puck up to the top shelf in the net. So Fred's eye level is 1.6 meters above the ground. So from here is 1.6 meters. The Eiffel Tower is 324 meters tall. So that means from here all the way to the ground is 324. I want you to calculate the angle of elevation. So I want to know theta to the top of the Eiffel Tower when Fred is 550 meters away from the Eiffel Tower. So in this scenario, right now we're looking at eye height. So we know it's 324 is from the tip of the Eiffel Tower all the way to the ground. I need to take out the fact that I'm not sitting on the ground looking up at this. I'm 1.6 meters off of the ground. So I take 324 minus 1.6. It's going to give me 322.4 is going to be my value that's representing this height. I want to know what angle is this person, or am I looking up? In this case, Fred's eye is looking up. Well, I'm giving you again the O and the A. So we're going to go tangent of theta is equal to 322.4 over 550. And since we're looking for an angle, we go tan inverse 322.4 all over 550. And that's what we'll plug into our calculator. So we're going inverse because we're looking for an angle measure. And we get an angle for theta, which is equivalent to 30.4 degrees. So Fred is looking up at the Eiffel Tower at a 30 degree angle roughly, which is close to a 30, 60, 90 triangle. So this is your application. This is to be able to apply the trigonometric functions accordingly based on the given information. So I'm hoping this stuff is starting to click. We are going to skip this section for now. We'll come back to that one. The last thing that I'm going to get to before we jump into non-right triangles is special cases. The special cases is the 30, 60, 90. The 90 is always the one that's across from the hypotenuse. And the 45, 45, 90, there's your hypotenuse again. So the two ratios that we talked about is that if you're going from a 30 degree to a 60 degree, if I'll draw a little triangle here for us, is that this distance is 1. If this is my 30 degree angle, then it's 1 square root of 3, 2. So it's whatever this value is, to get to the hypotenuse, you just double it. So if this was 4, then this is 8. If this was 6, then this is 12. This is 5. This is 10. So we double it to go from 30 the side across from the 30 to the hypotenuse. And then if we're to go to the 60-degree angle, we're just going to take it, multiply it by the square root of 3. So if this was 4, then it'd be 4 square roots of 3. So it'd be 1 square root of 3, 2, or 4 square roots of 3, 8. You're done. You can leave it in that form. You have simplified. Where in a 45, 45, 90, these two angles will always be the same. Because we have an isosceles triangle, so 45, 45, that makes this 1 and this 1. To get to the hypotenuse, you multiply by the square root of 2. Just like here, we are multiplying by 2 to get the hypotenuse. We multiply to get to the square root of 2 there. If you're working backwards, you divide by the square root of 2. Same thing over here. If I'm working backwards, I'm going to divide by 2 to get back to the 30-degree angle and then apply to the 60-degree angle. So, this is the ratio form of it. The formula parts is the hypotenuse is equal to 2 times the short leg. And the short leg is the one that's always across from the 30-degree angle. So this is your 30, 60, 90 formulas. You will need to know these if you're going to go the formula route. The other one is that the large leg is equal to the short leg times the square root of 3. And then for the 45, 45, 90, your hypotenuse is equal to your leg multiplied by the square root of 2. Keep in mind, this is the leg's always the one across from the 45-degree angle. The short leg is across from the 30. The short leg is the one across from the 30. This is the leg that's across from the 60-degree angle. So for those of you that are algebra, here's your formulas that you can use for the 30, 60, 90 triangles. Do you have to use them? No. Is it required? Absolutely not. It is extremely beneficial for you to be able to find that value. So let's just walk through a couple examples here. So for example, if I give you a 6, we're in a 45, 45, 90 triangle. So I know that this is x, this is going to be x. So to solve for that, I know it's an x square root of 2 ratio, or an x square root of 2. Well, I'm given the fact that the hypotenuse is equal to x times the square root of 2. So I'm going to plug 6 in for the hypotenuse, and I'll solve for x. So take 6 divided by the square root of 2, and we get x. 6 divided by the square root of 2 then is equivalent to 3 square roots of 2. That would then be my answer for this short leg. Using the formula that most of you guys have transitioned to, you're just taking 6. If you're going to this value, we're taking 6 and we're dividing it by the square root of 2 to get to x. And then since these are both 45 and 45, we know those have to be equal. Now in terms of this one over here, to find x, or let's just throw y in here, this is my short leg. So to get to my hypotenuse, we look back here. To get from short leg to hypotenuse, we just go ahead and double that. So 6 times 2 then makes y become 12. There's my final answer, because 6 times 2 is 12. To get to my large leg, looking back at the formula or the process, if we go from short to large, whatever number we have, we plug in front of the square root of 3. Same thing here. Your short leg times the square root of 3. So 6 large leg is equal to short leg times the square root of 3. My short leg is 6, so 6 square roots of 3 is equal to my large leg, which is the value then that is across from the 60-degree angle. This is a little videos, or the little examples of the 30, 60, 90 triangles. You can use the process. On the worksheet, I like for you to use the process, but when it comes to your test, if it's 30, 60, 90, and I give you the short leg, it's definitely easier just to double and multiply the square root of 3. I give you the legs in the 45, 45, 90. Just multiply by the square root of 2. Alright, so that's video 2 done right there. So this will be your next break where you'll be working on your in-class assignment.